So we've already talked about kinetic energy, and now we are going to talk about gravitational potential energy. So gravitational potential energy is the energy that an object has essentially because of how high off the ground it is. And so if I think about the work side of this, I need to do work to move this block. So I want to lift this block up a height of h. Well, in order to think about this in terms of work, I need to apply some amount of force and I need to push it up this height h. Well, because work is force times distance, I know the force that I'm going to need to push up on it, assuming I move at a constant velocity, is going to be equal to my weight or the gravitational force, which is mg. And then the height is just h. So therefore, the work done to lift this block up some height h is just going to be mgh. And because work is equal to your change in energy, the only kind of energy that is changing here is my gravitational potential energy. And so my gravitational potential energy is equal to mg times h. On your equation sheet, on the official AP equation sheet, you have the change in gravitational potential energy, or delta UG, is equal to mg. And instead of h, they use delta y because AP wants to specify that it's your change in height in the direction of the y direction instead of in the x direction. I usually write it as mgh. I don't care which way you write it. So this is for when you're close to the surface of the Earth. When you are far away, then you have to use this bottom equation. And that's G, like the universal gravitational constant, times m1 times m2 over r